Hey students, this is lesson 12.3. In this lesson we're going to learn how to find the measure of an inscribed angle and how to find the measure of an angle formed by a tangent and a chord. Go ahead and do the review here and I'll check back with you. Especially pay attention to what the word inscribed and circumscribed means. All right, the first thing we're going to use is called the inscribed angle theorem. Turns out that the measure of an inscribed angle is half the measure of its intercepted arc. So look at this diagram and see if you can fill in number 11 and number 12. So the measure of angle B is going to be 1/2 the measure of arc AC, which will be 45, and the measure of arc AC will equal 2 times the measure of angle B, which would be 120. So looking at this picture, we can figure out A and B by using the inscribed angle theorem. It turns out that B will be equal to 1/2. So this angle here, 1/2 of the intercepted arc, and the intercepted arc is this part right here, which is 56. And that's going to equal 28. And A will equal, well, A plus 56. So this arc right here, A plus 56, is going to equal twice the inscribed angle there. And you can see the inscribed angle right here. So 2 times 52. And that's equal to 104. So A plus 56 equals 104. So A equals 104 minus 56, which is 48. All right, you try that. Now some corollaries to the inscribed angle theorem. If two inscribed angles intercept the same arc, then they're congruent. That's corollary 1. Corollary 2, an angle inscribed in a semicircle is a right angle. And that makes sense since the semicircle is 180 degrees and the inscribed angle would be half that. And the opposite angles of quadrilateral inscribed in a circle are supplementary. So this one and this one would be supplementary, and so would B and D. All right, go ahead and fill in 14 through 18, true or false, using the diagram. All right, let's go ahead and use those corollaries. It says, what is the measure of each numbered angle? So on this first one here, we're going to say the measure of angle 1 is equal to 90, and that's because an angle inscribed in a semicircle, anytime you have a diameter that creates a semicircle, is a right angle. So angle 1 has to be a right angle by corollary 2 of the inscribed angle theorem. And B, what you should notice here is that this arc right here is the arc intercepted by both angle 2 and the 43-degree angle. So we're going to say that the measure of angle, let me label this C so I can talk about this a little more. The measure of angle ACB is equal to the measure of angle 2, which is equal to 43 degrees. And that's because they both intercept the same arc, AB. And if we needed to find that arc length, this would be 86. Not that we need to know that for this problem, but all right. Go ahead, you try that. All right, theorem 1212, the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So if we look at this arc right here, whatever that, however many degrees that arc is, this angle right here, if C is tangent, this angle will be half the measure of that intercepted arc. It's kind of like the inscribed angle theorem, only using tangent. All right, so go ahead and try and fill in 27 through 29, and I'll check back with you. Okay, let's use that theorem here. In the diagram, AC is tangent to the circle at B. If the measure of an arc BED is 214, what is the measure of angle DBC? So the measure of arc BD is equal to 360 minus the measure of arc BED. And that's going to equal 146. So the measure of arc BD is 146, and we know that the measure of angle DBC is equal to 1/2 of the measure of arc BD, and that's by the new theorem 1212. And we just got that the measure of BD is 146, so 1/2 times 146 is equal to 73. So basically what we're saying is this arc here is 146, and this angle right here is 73. Go ahead and try that. All right, we're up to the lesson check. Go ahead and do that, and we'll talk about this next time we meet in class.